everyone. Okay, we meet again for another subtopic of group 14, which is silicates. Okay, what is silicates? Okay, basically silicates, okay, is a mineral, mineral which containing okay, of silicon and oxygen. Okay, so the main element in silicates, okay, are silicon and oxygen. Okay, as we know that silicon and oxygen, okay, are the elements which abundant in Earth's crust. So no wonder that silicates, okay, is the most abundant mineral, okay, in the Earth's crust because of the abundance of silicon and oxygen. Silicates, okay, the silicates make up about 75%, okay, of the Earth's, okay, the Earth's crust, okay, which is they are the most valuable components of soil. Okay, silicon actually can form a strong bond with oxygen, which is called silicates, and basic unit of the all silicates, okay, is tetrahedral ion, which is SiO4 minus, and this is we call as a orthosilicates ion, or we can draw it, okay, as SiKO ion, and we can draw it in tetrahedral shape lah, okay, which is it contain of 4 ion. So this is the basic unit of tetrahedral of silicate of all the silicates mineral. Here are the classes of silicates, okay, for our syllabus, okay, which is silicates is divided into primary silicates, chain silicates, sheet silicates, and framework silicates. And the most common that you already learned before is framework silicate, which is framework silicate is a giant molecular structure, okay, which is SiO2, which is silicon dioxide. So this silicon dioxide is a framework silicates. Alright, okay, and then this is the mind maps of overall silicates, which contain classes of silicates, okay, primary, chain, sheet, and framework silicates. Alright, basically these all the classes of silicates are made up by basic unit of tetrahedral ion, okay, which is SiO4 minus. Alright, so now is we take a look for the framework silicate first, right? Okay, for framework silicate, okay, back to our page 101. Okay, this is the notes of 101. Okay, so take a look for the framework silicates. Okay, for framework silicates, okay, for a tetrahedral per unit tetrahedral are sharing of 4 oxygen atom, okay, which is all 4 oxygen atoms per unit tetrahedron are shared, okay, and 3D structure of silicon dioxide will be formed. Okay, so this is the structure of silicon dioxide that we already draw before. Okay, so let's draw again. Okay, we draw it in tetrahedral. Okay, okay, and then we just locate the oxygen. Okay, we locate the silicon atom here, and then in between of the silicon, okay, consists of oxygen atom. So here are oxygen atom. Okay, when you draw the structure, make sure you label all the atom involved. So this is the Si atom, this is the oxygen atom. Okay, so for framework silicates, okay, once again, one tetrahedron are shared, okay, the 4 oxygen, okay, atoms. Okay, So you can see here. So what is the repeating unit, okay, in this structure? So the repeating unit is SiO2. So this is the formula of the basic structural unit for framework silicate, okay, which is silicon dioxide. Okay, so this is about framework silicates. Now we move to the primary silicates. Okay, primary silicates, which consists of orthosilicates, pyrosilicates, and ring silicate. Okay, we take a look one by one. Alright, what is orthosilicate? Alright, orthosilicates, okay, it contain one tetrahedral unit. Okay, for orthosilicate, it's only contain one tetrahedral unit. Alright, so okay, for draw the silicates diagram, so you can draw it in 3D structure or 2D structure. Okay, me draw. Okay, so this is in tetrahedral shape, which is we draw it in 3D view. Alright, so it have 4 ion. So from this structure, so you can see that the formula of basic structural unit or repeating unit in orthosilicate is SiO4. Si, okay, O 4 atom here, and then it consists of 4 electron here. Okay, so this is the orthosilicate. Okay, in order to draw the 2D structure, in 2D structure, so you can draw like this. So this is represent silicon. Okay, and then this is the oxygen. Okay, bonded with oxygen, and then bonded with another oxygen here. Okay, and then bonded with another oxygen, and then we draw it like this. Okay, and then back view, it also contain one oxygen atom here. Okay, now we put the charge of this 2D diagram. Okay, we put in -1. Okay, 1 here. Okay, 1 here, and the backside view of oxygen. So they have 4 ion. So this is the orthosilicate structure. Okay, which is one tetrahedral unit only, and what you must know is the example of each silicates. Okay, for orthosilicate, okay, the common example is topaz. Say topaz, Okay. Second primary silicates is pyrosilicates. Okay, what is pyrosilicates? Okay, pyrosilicates contain 2 tetrahedral units by sharing one oxygen atom. Okay, so pyrosilicate is contain of 2 tetrahedral. Okay, 2 tetrahedral unit, okay, by sharing one oxygen atom. Okay, one oxygen atom lah. Okay, it share one oxygen atom. Alright. Okay, let's draw the pyrosilicate structure. Okay, for the first one is, okay, this is silicon here. Okay, and then it share with one oxygen is being shared with another tetrahedral. Okay, so now, okay, another oxygen here, right? Okay, so this is the ion. Okay, ion there. Okay, so you have done draw the structure of pyrosilicates. Okay, how to calculate, how to write the basic structure unit in pyrosilicate. Okay, so it consists of 2 silicon, okay, Si2 here. Okay, and then oxygen, it have 1, 2, 3, 4, 5, 6, and 7 O. Alright. Okay, while the charge, okay, unbonded oxygen, 1, 2, 3, 4, 5, and 6 ion. So that's why it forms 6 minus. So this is the pyrosilicates. Okay, let's draw the 2D structure. Okay, so you have SR here. Okay, this is SR here. Okay, and that is bonded with oxygen, which is it shared with another silicon here. Alright, and then it bonded with another O. Okay, another O here. Okay, so you form in 2D diagram. Okay, so same goes to the other tetrahedral. Okay, so don't forget that the back view is also consists of one oxygen atom at the back side. Alright, so this is the diagram of 2D of pyrosilicates. Let me put the charge here. Okay, minus here. Okay, minus. Okay, minus, minus. Okay, and the back side. Oxygen. So they have 1, 2, 3, 4, 5 and 6 charge. Okay. The example of pyrosilicate that you can memorize is hemimorphite. Okay, please take note the example for each silicate. Okay, now we take a look for the third primary silicate, which is ring silicate. Okay, what is ring silicate? Right, ring silicate have contain minimum 3 tetrahedral which form in a ring form. Okay, when each tetrahedral unit will share 2 oxygen atom. Okay, let's withdraw the ring silicate. Alright, so it consists of 3 tetrahedral which share with each each tetrahedral share by 2 oxygen atom. Okay, and then so it consists of another Si and then another O. So it will form a triangular. So don't forget that one Si is bonded with another 2. Alright, so and then unbonded oxygen will consist of ion. Okay, so this is the ring silicate structure and how to calculate the basic structural unit in ring silicate. Okay, it consists of 1, 2, 3 silicon. Okay, oxygen is consists of 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so it have 9 oxygen atom. Okay, and the charge it have unbonded 1, 2, 3, 4, 5 and 6 electron. So that's why for ring silicate it will form Si3O9 and 6 minus of basic formula structural. Okay, now let's draw the in 2D diagram. Okay, in 2D diagram, so we can draw like so it have Si here, Si here and Si here because it consists of minimum 3 tetrahedral shape. Okay, and then it will share with oxygen. 2 oxygen will be share here, so it will form share with another oxygen here. Bonded with another oxygen here. Okay, so this is the silicon part, alright, and then another oxygen. Alright, and then the back side of oxygen. Alright, and then the second of silicon here bonded with we draw it. Don't forget the back side of oxygen. And then we take a look for the third tetrahedral now is silicon bonded with 1 2, okay, and 3 oxygen. Okay, and then we draw it. Okay, then don't forget the backside oxygen. Okay, so this is the 2D diagram of ring silicates. Okay, we take a look at the charge here. Okay, now minus here. Okay, minus. Okay, and then the backside oxygen 1, 2, and 3. So the total charge here 1, 2, 3, 4, 5, and 6 negative. Okay, for ring silicate, okay, the minimum is a 3 tetrahedral, but we also can form more than 3, which is okay, it have Si 3, okay, O9, okay, this 6 minus, so we can times 2, which is we will get Si6 and O18 and 12 electron. Okay, for this part we form this kind of structure, okay, which is silicon consists of 1, 2, 3, 4, 5 and 6 tetrahedral unit. It will form this like this lah. Alright. Okay, and then example of ring silicate that you can memorize is, okay, benitoid, okay, which is usually we use it gemstones. Already covered about primary silicate, which consists of orthosilicate, okay, 1 tetrahedral, okay, pyro silicates consists of 2 tetrahedral, and ring silicate consists of 3 tetrahedral. Okay, so now, okay, we continue with chain silicate. And for chain silicates, alright, it have 2 types of chain silicate, okay, which are pyroxenes and amphiboles. Alright, let's see what is the chain silicate. Alright, for chain silicate, okay, it have single chain silicate, which is we call as a pyroxene. Okay, means that the tetrahedral are formed in a single chain. Alright, and then 2 oxygen atom per unit tetrahedron, okay, are shared to form a single chain. Okay, and the tetrahedral are arranged in alternate position to the left and right along the chain. So this is the structure of pyroxene. Okay, so you can see that it share 2 oxygen. Okay, 1 silica, 1 tetrahedral are shared by 2 oxygen atom, and it arranged in alternate form. Okay, alternate form. Right, so this is the 3D structure and this is the 2D structure. Now let's withdraw the pyroxene here. Alright. Okay, for the first thing is, what is the definition of pyroxene? Okay, is a single, okay, it is a single chain, okay, silicates. Okay, silicates. Alright, so in order to draw the pyroxene, the first thing that you must do is write down it in a single chain. Okay, and then arrange it in tetra in alternate position like this. Alright, alright, and then alright, you just fill up it by silicon atom, okay, in the center one, okay, which is 1 silicon atom with bonded with another 4 oxygen. Okay, so bonded it, so ini Si bonded with, okay, oxygen here, okay, and then bonded with oxygen, okay, bonded with oxygen, and don't forget the backside of oxygen. Okay, and then the second tetrahedron here, Si, okay, bonded with oxygen. Okay, and then, okay, another tetrahedron here, okay, silicon bonded with oxygen, okay, bonded with oxygen, and then backside oxygen. Alright, same lah, same with another tetrahedron, okay, and then backside. So this is the 2D view. Alright, and then now the charge in pyroxene here, okay, we put 1, okay, backside 2. Okay, so 1, 2, 1, 2, and 1, 2, and so on lah. We also can draw it in 3D view. Okay, so SI, okay, and then bonded with O here. We follow the 2D diagram, it's easier to you. Okay, and then this O also, okay, shared with another silicon here. Okay, so like this. Right, and then same goes lah, same goes to, and then it's repeating. Okay, repeating here. Okay, then we will take a look for it. Okay, so each silicon must bonded with oxygen. Okay, one silicon we bonded with another for oxygen. Okay, and then oxygen and oxygen. So this is the 3D view of pyroxene. Okay, and then charge. Okay, so okay, don't forget so another O, okay, for pyroxene it must share with 2 oxygen. It's also bonded with another tetrahedron. Okay, so now is charge. So this is the charge. So unbonded, okay, unbonded oxygen, okay, contain electron lah. Alright, okay, done drawing the structure. Okay, but then, okay, how to write the basic structural unit? Okay, for pyroxene, okay, if you can see here, okay, what is the repeating here? Okay, so we take a look that, okay, so we can see that this is the repeating. Okay, the repeating. Okay, and then it's followed by another one. Okay, this is another one. Okay, this is the repeating. Alright, so it consists of one SI. Okay, one SI here. Okay, and then it consists of 1, 2, and 3 O. Okay, so 3 oxygen atom. Alright, and the charge which is unbonded oxygen consists of 2 electron. Right, so that's why for pyroxene, okay, its basic structural unit is SiO3 2-. Right, and same lah, if you want to see the second one also same. So we take this, okay, and then we break. Okay, at this is the another one punya. Right, okay, and then the example of pyroxene that you can memorize here is jaded. So make sure you memorize the example of pyroxene here. Okay, now the second chain silicates is amphibole. Okay, what is amphiboles? Alright, amphiboles. Okay, amphibole is a double chain silicates. Okay, which is 2 pyroxene chains are joined by sharing another oxygen atom to form double chain. Alright, so this is the example. It have more than one pyroxene joined together. So this is one pyroxene and this is another pyroxene. So we call it as a double chain silicate. It consists of 2 pyroxene. Okay, now let's draw the structure of amphibole. Okay, so because of the structure, okay, the amphibole is 2 pyroxene chain, so it have a double chain. Okay, amphibole is a double chain silicates. Okay, alright. So in order to draw the double chain silicate, which is amphibole, okay, so now you draw it in double chain, 2 chain lah. Okay, you draw it first in 2 chain shape. Okay, and then draw the pyroxene first in alternate arrangement. Alright. Right, so this is one pyroxene here, and then you draw it another pyroxene below. Okay, right, like this. Alright. Okay, so basic shape you have done it. Okay, and then continue by fill up the atom. Okay, now the center one is silicon, silicon, silicon. Silicon, silicon. It have silicon here, silicon, silicon. Alright. Okay, and then each of silicon, okay, make sure is bonded, okay, by 4 oxygen. Okay, oxygen, and then the oxygen at the back side. Okay, and then same goes to another one lah. Okay, filled up by oxygen here, and then the center one, and then another silicon bonded with another 4 oxygen atom. Okay, and then the center one. Okay, and then okay, you just complete it. Okay, complete it lah. Okay, and then continue the below one, because it is a double chain. Double chain. Alright. Okay, and then you complete it. Now the charge in amphibole. Okay, we put minus, 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 and backside 1 minus here. Okay, the edge, then the backside. Okay, this one is connected, bonded with another tetrahedron. Okay, this all. Okay, the backside one is contain of 1 minus here, and the backside here also contain of minus, which is unbonded there. Okay, and then okay, backside there. Okay, and then backside there. Right. Okay, and here charge. So 1, 2, 3, 4, 5, and 6 electron. Okay, we have done draw in a 2D diagram. Okay, now let's try to draw the 3D diagram of amphibole. Okay, we start by you draw it into chain lah, double chain. Okay, draw in double chain first. Okay, and then right. Okay, the line, the chain is consists by oxygen. Alright, and then Si here like this. Okay, class. Okay, and then have another Si here. Okay, another oxygen. Okay, and then one silicon must bonded with 4 oxygen here. Okay, and then this one continue by another O and another silicon here. Okay, and then another oxygen here. So this is how you form. Okay, and then continue by Si here. Oxygen. Okay, and then bonded with another Si, another O. Okay, SiO bonding. Okay, and then another O here, and then we have Si, which bonded with this both. Alright, this is how you draw it. Okay, and then you draw it in a large diagram lah. You get double chain here, so you just complete it. Okay, in a double chain. Okay, and then this same goes to oxygen. Okay, now okay, you take a look for the unbonded oxygen. Make sure it consists of charge. Okay, charge here, charge. Okay, charge. Okay, another charge. Okay, but now we check each. Make sure that each silicon must bonded by 4 oxygen. Okay, this one is okay already bonded. Okay, this Si okay bonded 3. So make sure you draw another one lah. Okay, another one O. Okay, and then this silicon also 1, 2, 3. Okay, put another O here. Alright, and then okay enough. Okay, this one. Okay, also have another O here, another O here. Okay, so it's already complete. Alright, but then how to know the basic structure, basic structure unit for amphibole. Okay, so now I want to show you. Okay, we take a look what is the repeating unit of this diagram. Okay, if you see that the pattern is like okay 1, 2, 3, and 4 silicon here. So this is the pattern of repeating. Okay, followed by the second one, 1, 2, 3, and 4. Okay, this one is another repeating unit. Okay, and then so on lah. 1, 2, 3, and another silicon here. So this is the pattern of repeating unit. Okay, in amphibo. So okay, let's circle it. Okay, I will circle. Okay, the repeating here, the repeating unit. Okay, so this is the sharing one. So I break at the sharing oxygen. Okay, so now we have. Okay, so this is the repeating unit. Okay, of amphibo. Okay, followed by this. Okay, and so on lah. Okay, let's calculate. Okay, the silicon 1, 2, 3, and 4. Okay, we have 4 silicon here. We have 4 silicon. Okay, let's calculate the oxygen atom. 1, 2, 3. Okay, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 oxygen here. So the bonded one, okay, so I break here. So this is belong to another unit. Okay, then charge. Okay, calculate the charge class. Okay, the charge. Okay, now we have 1, 2, 3, and 4. Okay, don't forget okay, ni the back side here. Okay, they also unbonded oxygen. So 1, 2, 3, 4, 5, and 6. So we have 6 electron in amphibo. Alright. Okay, and then we take a look. Okay, our notes. Alright. So for amphibo, that you must know here is the example of amphibo. Okay, asbestos is this famous one lah. Okay, the asbestos is the example of amphibo, which is the uses of asbestos as a heat insulator, which is we use it to make fire retardant coating and shielding sheet. Okay, for next classes of silicates is sheet silicate. Okay, what is sheet silicate? Okay, sheet silicate. Okay, sheet silicate. Okay, which is each tetrahedral unit shares actually two or three. Okay, shared by 2 or 3 oxygen atoms, which is only formed in 2-dimensional infinite sheet silicate, which form. Okay, and then it have weak van der Waals forces hold them together. So this is the structures of sheet silicate, which is it have more than 2 pyroxene silicate. Okay, this is 1 pyroxene, 2, 3, and 4, and so on lah. So make sure that it have more than 2 pyroxene here. Okay, which is each tetrahedral unit. It is shared by 1, 2, and 3. Okay, if upper tetrahedral, it will share 2 oxygen only, and in the middle it can share with by 3 oxygen atom. So for sheet silicates, okay, for sheet silicate, right, what is, okay, so it will share, okay, it share, okay, by 2 or 3 oxygen atom. Alright, so now, okay, let's draw the sheet silicate here. So when sheet silicate, so meaning that it's more than 2 chain lah. So you must draw it more than 2 chain. Alright, okay, so we can draw it. Okay, you draw it. Okay, like we draw for pyroxene earlier. Okay, and then, okay, we draw it some more. Okay, and we must add it. Okay, alright, and then, okay, we have here. Okay, alright, so if you want to add it some more, okay, just add. Okay, so this is the chain for sheet silicate, and then you just complete it by put the Si lah. Si bonded by oxygen. Okay, Si. Okay, oxygen. Okay, oxygen and silicon here. Okay, you just occupy all the atom involved. Okay, you complete all of this. Okay, now I have complete to draw the sheet silicate here. Okay, so now, okay, what is the repeating unit? Okay, our basic unit in sheet silicate. Okay, what is the repeating unit that you can see here? Okay, so if you realize that this is the repeating unit, okay, of sheet silicate. Okay, you can see this is one repeating unit here. Okay, this is the repeating unit, the same pattern, is it? Okay, so you have below one here like this. This is the repeating unit. So this is the basic structure unit for sheet silicate. Okay, or we can draw it. Okay, so I take one I pick one basic unit. So we have Si here, O. Okay, and then O. Okay, and then another Si here, bonded with O. Okay, O. Okay, so then don't forget so the outside. Okay, the another oxygen here. Okay, so another oxygen here. So, okay, so this is the repeating unit of sheet silicate. So this is the sharing with another Si lah. So this belong to another tetrahedron. So what we have here, 1, 2 silicon. Okay, 2 silicon atom. Okay, and then okay, and this one also bonded with another lah. Okay, and then it's charged. Okay, so 1, 2, 3, 4 and 5 oxygen. Then we have 1 and 2 charge here. So this is the sheet silicate formula. Alright, so this is the basic unit. Alright, that I take from a part of sheet silicate. Alright, okay, then okay, what is the example of sheet silicate that you can memorize here is you have okay, mica. Okay, also we have top. Okay, usually top we use it in powder. Face powder we use talcum. So this is the example of sheet silicate. So what is the difference between sheet silicates? Okay, sheet silicates and framework silicate is sheet silicate is in a 2D form. Okay, so while for framework is in a 3D form. So from framework silicate with that we already draw earlier. So this is the diagram in 3D. Okay, and this is okay the structures of framework silicates. Alright, which is Si. Okay, which consists of 4O and it's shared by 4 oxygen atom are being shared. Okay, so this is the framework silicate. Alright, okay, then the example of framework silicate is a zeolite. Zeolite is the famous example for framework silicate. Okay, but this zeolite, okay, zeolite is actually synthetically manufactured, okay, in 3D dimensionally, which also called as a crystalline, okay, alumino silicates. Because for zeolite it also contain of aluminium silicate. Okay, if you can see here, okay, it's located that some aluminium, okay, in the structures of okay framework silicate. Okay, so it maybe also contain of here aluminium, okay, and here aluminium. So this is we call zeolite or alumino silicate. So what is the uses of zeolite? Okay, if you can see here that the alumino silicates or zeolite structure, it have pores or cavities. It have pores here. Okay, you have pores in the structure. So that's why for aluminosilicate, it can act as molecular sieves. Okay, molecular sieves. Okay, which is it being used to separate the straight chain hydrocarbon from a branch chain hydrocarbon. Okay, which is the straight chain will go through the pores. Okay, and then it will trap the branch chain. Okay, and then second uses of zeolite as ion exchangers. Okay, as ion exchangers. Okay, which is the function as to soften the hard water. Okay, you know that what is the hard water? We have calcium, and magnesium ion. So how the function, we can write the equation here. So this is the zeolite, which is when we put in the hot water, aqueous, so it will bonded with zeolite. Alright, this calcium ion, this hot water will bonded with zeolite, and it will drain out the sodium ion, so it will form calcium zeolite lah. So we can soften the hot water, so it will form sodium ion. Alright, the third uses of zeolite we have is it can act as a catalyst. So we can see why the basic unit for framework silicate is SiO2. So we can see here is the repeating unit. Repeating unit. This is the repeating unit of framework silicate, which is SiO2 lah. So SiO2, right? So that's why the basic unit for framework silicate is SiO2. Okay, then we take a look back for the framework silicates, which is the example given are quasar, feldspar clays, and zeolite that I mentioned earlier. So zeolite and quasar is the most famous of framework silicates. Alright, so this is the whole notes about silicate that you must know. How to draw for each classes of silicate, and you must know the basic unit structure for each classes. Alright, and also you must know the uses or the example for each classes.